What's up, everybody? Mr. Spottleson here. Today we are going to look at section 11.8 still. Instead, today for day 2, we're going to look at just dividing radical expressions. Monday, we did all multiplying radical expressions. All right. As far as the homework, I'm going to hold off on going over it just because I've got a lot of people that still haven't turned it in. It's all right. You have till Friday, but I figured I'm just going to wait to do all the answers to that yet. Okay, just a little bit. All right. So with dividing, okay, we for dividing we have, first of all, to look at that, we had 3 rules that kind of said, not 3 rules, yeah, they were kind of 3 rules, okay, and they basically were like, this is not simplified if, okay, and the first one that said it's not simplified is if there's a fraction underneath a radical. Okay. So in this case here, I have radical 5 over 4. That's not simplified because there's a fraction underneath. And I can solve this to radical 5 over radical 4. And then that simplifies down to radical 5 over 2. And I get an answer there. Okay. That is my first one. All right. There's other examples here where there was other situations where if I have something like radical 20 over 5. Okay, radical 20 over 5 has a perfect square that can factor out, so this radical is not simplified all the way. I can do radical 4 times radical 5 over 5, and I get 2 radical 5 over 4. Oh, not 4. 2 radical 5 over 5 as my simplified version there. So if I could divide the perfect square out, that meant it wasn't factored all the way. The other way that we had was if there was a radical in the denominator. Okay, and the way that we get rid of a radical sign in the denominator is something called rationalizing the denominator. And we do this by multiplying the bottom by the same radical, because we already know that this is just 3. Now, we still have to take into account for the bottom, or I'm sorry, the top. Now, in order to balance this equation out, I have to multiply the top by the same radical. So in the sense of this equation, if I multiply this by radical 3 over 3, it's really just multiplying it by 1, and I'm not changing my fraction at all. Now when I multiply this, I'm going to get radical 12. And obviously I can divide a perfect square out of 12, so I'm going to get radical 4 times radical 3 over 3. And then I'm going to get 2 radical 3 over 3 as my answer. So there were 2 things that needed to be simplified in that example. But the main thing we want to focus on is this step called rationalizing. Okay? I'm going to move us now to these 4 steps to rationalize. Okay? These 4 steps to rationalize, I would like you to write down, and it's very important that you follow these on the homework. Okay? Thing about these problems are you can still solve these if you don't follow these 4 steps, but it's going to be a lot harder. Okay? If you don't follow the steps, you're making the problems more difficult. Okay? So, to start out here, the first step is to simplify any fractions both in or outside of the radical. Okay? Simplify all your fractions first. Step 2 is to reduce any radicals. So that would be to make sure that there's no perfect squares that can be divided out like we did in step 2 here. So reduce any radicals. Step 3 then is to rationalize. Okay, I saw it all last year. Kids get so excited because they know how to rationalize a denominator. And when they go to rationalize the denominator, they do it before they do simplifying or reducing. And then they get these huge numbers that they don't know how to work with, and they have a lot of work to do. Okay, don't do that. And then step 4 is to simplify fractions and reduce radicals if needed. Really? Step 4 is only there if you're somebody that can't follow steps 1 and 2. And you jump right to rationalize, then you have to do your simplifying and reducing. Very rarely do you have to do step 4 if you follow step 1 and 2 correctly. Okay? All right. For today's notes, we got a pretty short day. I'm just going to do 6 examples looking at these, and then you guys are off for the rest. And then you guys are off to start the assignment. Okay. All right. The first one here: radical 11 over radical 3. Okay. Can I simplify the fractions at all? No. Okay. 11 over 3 does not simplify at all. Can I reduce any of these radicals? No. There are no perfect squares that'll divide out of 11. So I can go right to the rationalizing here. Multiply by radical 3, multiply by radical 3. This is going to give me 33 over, and then this is radical 3 times radical 3. We know that that equals radical 9, which is just 3. Once again, we can do step 4. Can I simplify these at all? Nope. If this was under a radical, I could, but since this one's under a radical and this one's not, there's nothing I can do. And can I reduce the radical 33 at all? There are no perfect squares that divide out, so that ends up being my answer there. Okay, radical 13 over radical 5. Same question I'm going to ask. Can I simplify any of these fractions? No. Can I reduce any of these radicals? No. So I'm just going to multiply here by radical 5. Whatever I do on the bottom, I got to do the top. So this is going to give me radical 65 over 5. Once again, can I reduce these fractions? Nope, cannot. And are there any perfect squares that I can divide out of 65? I would suggest you write them out one time whenever you take these quizzes, but no, I can't. Oh no. So that ends up being my answer there. Okay, moving on to the next. We've got radical 13m over radical 20. Okay, I cannot simplify these fractions at all, but I can simplify this first. Okay, so I have 13m over, and this is radical 20, which simplifies to radical 4 times radical 5. Okay, so then this gets me 13m, and this gets me 2 radical 5. Okay, from here now, we can go ahead and rationalize because we've taken care of steps 1 and 2. All right, so I'm going to multiply this by radical 5, and I'm going to multiply this by radical 5. Okay, down here, this right here multiplied is just going to be radical 65m. And this right here is going to be 2 times 5, which is going to equal radical 65m over 10. Okay, I can look at that again. There are no perfect squares, like we said in the last problem, that can divide out of 65, and it's just one m, so there's no doubles to factor out that way. So my answer is going to be radical 65m over 10. Okay, radical 7a over radical 12. Okay, there is a perfect square that I can divide out of 12 here. I'm going to have 7a over, and then radical 12 here is going to be radical 4 times radical 3. So I'm going to have 7a over 2 radical 3. Once I've done that, now I can rationalize by multiplying by radical 3, multiplying by radical 3. When I multiply this here, this is going to give me radical 21a over, and here I'm going to have 2 times 3. My answer is then going to be radical 21a over 6. Okay. All right, moving on. Now this one, if you try to do this without simplifying this radical 80 first, good luck. Okay. First thing I'm going to do is try to simplify this radical 80. Okay. Go ahead and pause this video and simplify radical 80. All right. To simplify radical 80, we need to think of a perfect square that I can divide out of here. Well, I know that the perfect square that can divide out of 80 is going to be 16. So I have radical 16, and then I'm going to have radical, what would that be? That would be 5, right? 16 times 5. Oh boy, brain dead. Yep, radical 5. So I'm going to have 2 times 4 times radical 5, which is going to simplify this whole top. I'm including my 2 in there now, is going to be 8 radical 5. Okay, so I'm going to go back up here, and my top now is going to become 8 radical 5 over radical 7. I've done a huge step here. Okay, from here now, I can write this as 8. I'm going to write it down here as 8 radical 5 over radical 7. I'm going to multiply by radical 7, multiply by radical 7, and I'm going to get 8 radical 35 over 7. Okay, I can look at this 35 here. There's no perfect squares that divide out of it. My answer is right here. Okay, again, just doing this little simplifying or reducing the radical up here saves me a lot. Okay, last one for today is radical 50x over radical 10. Again, if you don't do this the way I'm going to show you how to do it, good luck. Okay, radical 50x over radical 10 is the same as, again, these can simplify. 50 over 10 can simplify. This is the same as having one big radical and having 50x over 10. And 50x over 10 just simplifies to 5x. And that's my answer. There's nothing else I can do there. Okay? So, when you follow the rules here, shouldn't have much of a problem. It's when you start wandering out a little bit and trying to get too excited. If I would have not simplified this fraction, I would have multiplied both by radical 10, and then I would have had radical 500 that I would have had to simplify, and it would have been a pain. Okay, but if I just simplify there, a lot of things come easier. All right. You have a quick assignment, 31 through 41 odd and 46 through 51. I think some of it's a review of the multiplication, and then the rest is just the division. Again, it's due on Friday. And like always, any questions, any concerns, any suggestions, anything you might have, send me a reminder. Hop on Canvas Conference. I'll be on Canvas Conference today. If you're watching this on Wednesday at 12:30, and I'll be on Thursday, I'll be on Canvas Conference at 8:30 in the morning. I'm sure all of you want to get up and talk to me then. All right. Everybody have a great day. I will see you next time.